Hello everyone, welcome to today's class. Now we are going to do an extension of a topic that we have done before, that's in the past, which is also in the videos on my channel here, which is algebraic fraction. In the past video on this topic, we did algebraic fraction of uh, the kind of fraction that has just numbers at the denominator. What I mean numbers at the denominator is that when you have a fraction or algebraic fraction of this nature, okay, so when you have an algebraic fraction of this nature, that is the kind of class that we've had in the past, which is on this channel, so you can check it out. But this time around, we are going to look at when you have a polynomial or a linear expression at the denominator. What I mean by a polynomial or linear expression is a situation where you have 2 over, let's say, x squared plus 1, things like this. Okay, so this is an algebraic fraction, this is an algebraic fraction, but they are not the same because this one has numbers at the denominator, while this one have what? uh, a polynomial, be it a quadratic, a cubic, a linear expression at the denominator. So this is the type that we are going to explain in this class today. So first of all, I always talk about use of brackets in algebraic expressions. What I mean is that when you have something like this, let's say x plus 2 over 3 plus 5x, I always advise that you put these things inside brackets. It will make you to avoid the little mistakes or errors while solving your problems. So what I always advise is that when you have an expression like this, all these expressions, both at the numerator and the denominator, so long as it's an algebraic expression, you should put it inside a bracket. It will help you to avoid minor errors. So when you have something like this, you put your x plus 2 in a bracket and you put your 3 plus 5x in a bracket. So that's the first thing I want to say. Then the next thing I want to say is the use of minus or the factorization of minus outside the bracket. What am I trying to say? What I'm trying to say is that if you have minus x plus a, okay, we can actually factor out minus outside the bracket. So when you factor out minus outside the bracket, you're going to have minus x minus a. So we should know that these two things are the same, okay? Because when you open this bracket, minus times s will give you minus s, minus times minus a will give you plus a. So what I normally say, or the way I normally say it, is that when you bring out minus, the sign inside the bracket will do what? Will change, okay? Now, where is this thing useful? It's going to be useful for us when you have a minus x, that will give you minus x minus a. So you can see what have happened here. Because I'm bringing minus outside, the numbers have interchanged. Okay, so how does this thing happen? If I have a minus x and I decide to bring that minus outside, a will change to what? Negative, while minus s will change to what? Positive. Of course, you can actually switch your numbers. So when you take this one here, carry this one, bring it back, it's going to give you minus x minus a. So you can see that they are still maintaining um, their signs. Okay, so that's what we have there. So all these things that I'm explaining is actually very important before we dive into this particular topic. Okay, so having said that, let us look at other things that we also need in order to equip ourselves very well to tackle this topic called algebraic fraction. So another thing that is very important that you should know is that when you have x plus a over, let's say, x plus 2a, please, you can't divide, okay? There's nothing here you can divide. If you go and do this, that is wrong. Okay, if you also have x plus a over x and you go and do this, that is also wrong. Please, we don't do this. Okay, we don't do this because when you do it, it's not mathematical. Okay, and when it's not mathematical, of course, that's wrong. Okay, so please don't try this whenever you are solving problem on algebraic fraction. So another thing is that we have made some videos on factorization of algebraic expression. So we are going to look at this type of uh, factorization. Let's say you have a square plus 2ab minus, okay, let's say plus b square. Please, we have to get used to a quadratic expression of this nature. Okay, and how do you factorize this? If you know how to factorize your quadratic expression, you can still check it out in our video, how to factorize quadratic expression. It's not a problem. All you need to do is to ignore what? Ignore b. Just ignore b, take b as 1 and factorize. So when you want to now expand, just be putting your b. Okay, so for example, if I want to do this, I will take b as as a constant, as if it's not there. So what is the factor of b? 1. What is the factor of a? 1. So 1 times 1 will give us 1. 1 plus 1 will give us what? 2. So you expand this one, a square plus ab plus ab plus b square. You can see that when dealing with this, I do not consider b, but when I have gotten the numbers that I need, I will now put back my b. Okay, so you have to get used to factorizing an expression like this, because definitely under this topic you are going to need it. Now, since we have touched everything that we need to know, let us go and simplify algebraic fraction. Remember how we do it here? We move from simple problems to a little bit difficult problem. So I say move from simple to complex. So let us take some few examples on simplification of an algebraic fraction. So our first problem here is h square minus hk over hk. Okay, so please, like what I said before, don't go and cancel hk. It does not work that way. Okay, so this will give us what is common here. H is common, so you bring it out, open bracket, what's remaining? H minus what is remaining? K over hk. So they are multiplying now. They are multiplying. You can actually do this. So that will give you h plus k over k. And please don't go and divide k and k. So that is your answer. Let us go to example number 2. So in our example number 2, we have a square minus b square over b square minus ab. All you need to do, factorize this, see what is common, and divide. Okay, so it's very simple. This is a difference of 2 square. In our video, if you check our channel, you will see how to factorize difference of 2 square. So let's factorize this. That will give us a minus b into a plus b, all over b is common here, so you bring it out, you now have b minus a. Now there's nothing you can divide for now until you have to do a little bit mathematical manipulation there. Remember what we said about this, that when you have a minus b, that will give you minus b minus a. So what does that mean? If whenever you have a minus b or a number minus another number, you can factor minus out and have b, it will just interchange. Just when you bring out minus, the expression will do what? Will interchange if minus is at the middle. I have shown you at the beginning of this video how we got this. So applying it there, you have a minus b into a plus b all over minus b. I'm bringing out minus now. You now have a minus b. So this one and this will go. Minus, we don't leave it at the denominator, so you bring it up. So that will give you minus a plus b over b. Okay, So let us move to example 3. So our example 3 here is c square minus 2cd plus d square all over c square minus cd. So factorize the numerator and factorize the denominator. You will definitely see something that is common. You divide it and make it simpler or leave it in a simpler form. So let us quickly do that. Here we are going to have c square minus cd minus cd plus d square all over c square minus cd. Okay, so these two will give us c square minus cd minus cd minus d square. What have happened there is that I have factorized minus out. So this one is now plus cd. This one is now minus d square. So all over, do the same thing here. C into c minus d. Now, you keep factorizing. Remember, we are just trying to factorize the numerator. So that will give us c into c minus d minus d into c minus d all over c into c minus d. So let's finish it up here. So that will give us c minus d into c minus d all over c into c minus d. So this one and this one will cancel out, and we have c minus d over c. So that's how we can solve that. Let's solve one or two more examples before we move to other things, other subtopic under algebraic fraction. So look at this kind of question. We have a square minus open bracket b plus c all squared all over c square minus open bracket a minus b all squared. Now, it does not change it. It does not make it not to be a difference of 2 square. This is a difference of 2 square, so we treat it as such. So that will give us a into a minus b plus c into a plus b plus c. So you can see where I have applied my difference of 2 squares. So the next thing is to also do the same at the denominator. C minus a minus b into c plus a minus b. Okay, so we are going to open the whole bracket and see if we have anything that look alike so that we can be able to cancel it out. So that will give us a minus b minus c into a plus b plus c all over c minus a minus b into c plus a minus b. Okay, now if you watch here, is there anything we can do? Let's see. So with this now, I think if we change the sign, everything inside this bracket is going to look like this, because c will change to minus, a will change to plus, and b will change to minus. So how can we do that? A minus b minus c into a plus b plus c all over, bring out minus outside here, c will become minus, a will become plus, b will become minus, into c plus a minus b. And since c is minus, a is plus, and b is minus, this and this can go. Then you bring your minus up here, you have minus into a plus b plus c all over c plus a minus b. So we have gotten our answer. So we have solved about 4 problems on simplification of algebraic fraction. Try to solve different kind of problem. So the next thing we are going to look at is multiplication and division of algebraic fraction. So the first problem we are going to have under multiplication and division of algebraic fraction is a square minus 4 all over a square minus 3a plus 2 divided by a all over a minus 1. So all you need to do factorize this. Of course, you have division here, you change it to multiplication. So let's factorize up. If you have this up here, difference of 2 square, of course, you can see that this is a square, this is a square. So that will give us a square minus 2 square all over. You factorize the denominator, that will give us a square minus a minus 2a plus 2. Change this one to multiplication times a minus 1 over a. So the up one here will give us a minus 2 into a plus 2 all over. The down one here will give us a square minus a minus 2a minus 2 times a minus 1 over a. So simplifying further, we need to factorize the denominator completely before we can be able to cancel out anything. So that will give us a minus 2 into a plus 2 all over a into a minus 1 minus 2 into a minus 1 times a minus 1 all over a. So that will give you a minus 2 into a plus 2 all over, what is common here, a minus 1 into a minus 2 times a minus 1 all over a. A minus 1 will go, a minus 2 will go. What we have left is a plus 2 over a. So that's our answer. So the first problem we solved in multiplication and division gave us that answer. Let us move to the next problem and see if the same principle can be applied. So let's look at how we can solve this. So by now, I believe that you are very, very much familiar with what we are doing. Factorize everywhere. You see things that you cancel out. You cancel them out and get your answer. So that's what I'm going to do. So I will be a little bit more fast this time because we have solved or we have factorized a lot. Okay. So what are we going to do? N square minus 3 square all over n into n minus 1. So I just factor n out here times this one will give us n square minus n minus 2n plus 2 all over. This one will give us n square. That will give us plus 3n minus 2n minus 6. Okay, so factorizing, I need to factorize this, I need to factorize this completely, I need to factorize this completely. In fact, I need to factorize all of them completely. Okay, I have factorized this one, so remain others. So let's do that gradually. So that will give us n minus 3 into n plus 3 all over n into n minus 1 times n square minus n minus into 2n plus, oh, this one will change because we have brought minus outside, so minus 2 all over n square plus 3n minus 2n plus 6. Okay, so let's finish it up here. So that will give us n minus 3 into n plus 3 all over n into n minus 1 times n out n minus 1 minus 2 out n minus 1 all over n out n minus n plus 3 minus 2 out n plus 3. Okay, so factorizing completely now, n minus 3 into n plus 3 all over n into n minus 1 times n minus 1 into n minus 2 all over n minus 2 into n plus 3. Now, all this I'm doing is just because I want to show you how I'm getting all this, okay? if you're in exam hall, immediately you move from here, you can go straight and factorize. Okay, you can go and do your factorization in your rough sheet, factorize, put it here, cancel out what you see that is common, then have your answer. It's as simple as that. But I can't just do it here because I believe we are all learning together. So I need to show how to do this step by step. Okay, but that does not mean that in exam hall you cannot skip some of all these steps to get your answer. It's allowed. Okay, so we are done factorizing. So the next thing now is this multiplication. So I can cancel out what are common. So at the end of the day, what we have is m minus 3 over n. So you can see why they call it simplification, because you can see the whole of this is actually m minus 3 over n. Okay, so let us look at another problem, probably the one that has both, that have both multiplication and division. Let's see how whether it's going to be more difficult than what we have been doing, or whether it's also going to give us the same thing with compared to what we have been doing. So this is our example 3. You can see that this question has both multiplication and division. So what are you going to do? It's very simple. All you need to do is to first of all go and factorize each expression. So I'm going to do the factorization of each expression here, then we can now put it there. So let's factorize a square plus ab minus 2b squared. Okay, so this 1 times minus 2, 1 times minus 2 will give us minus 2. Then two numbers that will give us this is minus 2 plus 2 times minus 1 will give us minus 2, and 2 plus minus 1 will give us 1. So that will give us a square plus 2ab minus ab minus 2b squared. So that will give us a into a plus 2b minus b into a plus 2b. So that will give us a minus b into a plus 2b. Okay, so if we factorize the up one here, that will give you a minus b into a plus 2b. So let us go and factorize the denominator. So the denominator will give us a square minus 3ab plus ab minus 3b squared. So that will give us a into a minus 3b plus b into a minus 3b. So that will give us a plus b into a minus 3b. Okay, so let's come and do that here. That will give us a plus b into a minus 3b. Okay, so we are done factorizing the first expression, both the numerator and the denominator. Let's factorize the second one. The second one will give us, of course, difference of two squares. So we have a plus b into a minus b all over the denominator. That will give us b into a plus 2b. Okay, going to factorize this one, the numerator, let's take care of that. That will give us a square minus ab minus ab plus b square. So that will give us a into a minus b minus b into a minus b. That will give us a minus b into a minus b. Okay, so let's come back here. So that will give us a minus b into a minus b all over. What we have here, a is common, so you bring a out, so you have a minus 3b. Now we have division here, so we have to first of all change to multiplication. So cancel out things that need to be cancelled out. Then we have our answer. I think that's all. So that will give us a minus b into a plus 2b all over a plus b into a minus 3b times a plus b into a minus b into b into a plus 2b times, this one will come up, this one will go down, a into a minus 3b all over a minus b into a minus b. So let's do the cancelling. So a plus b here, a plus b here, a into a minus 3b here, a minus 3b here, a plus 2b here, a plus 2b here, a minus b here, a minus b here, another a minus b here, a minus b here. So what do we have as our answer? At the numerator, we have only a left, and at the denominator, we have only b left. Please note that all these ones is our rough work. So this is where we have our answer. So you can see how simple that is, okay? So the only thing that is needed in addition and multiplication and division of algebraic fraction is to be able to simplify or factorize all the expressions given. Immediately you can be able to factorize all the expressions given. The next thing to do is to cancel out what needs to be cancelled out, and you have your results as simple as a over b. Okay, so let us look at addition and subtraction of expressions in this form. Let's see what we are going to have.